Hello and welcome to TidyX episode 3. It's where we go through and explain submissions to the Tidy Tuesday project and explain how the code works to try to make it more approachable to everybody. Tidy Tuesday is a project put on by the R for Data Science learning community to get people to practice their R skills with new data every week and visualizing it. So my name's Ellis Hughes. I'm a statistical programmer at Fred Hutch Cancer Research Center in Seattle, Washington.
And I'm Patrick Ward, and I do data analysis in sport.
All right. So the data this week is from the Brain Injury Association of America. It's specifically on traumatic brain injury, so TBI for short. And so the goal of this is to spread, or this week's data is to spread awareness of just how common TBI are in both the civilian and military populations, because it is everywhere, and we're living in a stressful time this moment. So Patrick and I are recording in separate locations due to COVID. So you keeping safe over there?
Trying to as safe as I can stay by myself in my apartment with my books and guitar and music.
Yeah. I'm doing the same over here in my apartment in Seattle here. So this week's submission that we're going to be looking at is from Raniere Silva. I hope I said your name correctly. So he submitted this great post that we saw using radar plots. And using facets to show different age groups. So here he's showing one plot of just all the potential injury mechanisms that can happen. And then he shows another plot here where he's actually removed one of them that was so much larger than all the other populations. And so he unfortunately didn't share the code immediately with the tweet, but we reached out to him because we thought the submission was great, and he kindly shared it with us. And so rather than GitHub, which is where a lot of people seem to be storing their code, he has it on GitLab. And so we will go through his code now. Thank you, Raniere, for letting us do this. All right. So the first step here that he does is he loads the library that he's using. So this code is thankfully relatively straightforward. So he only has to bring in one library, which of course is Tidyverse, which does actually bring in a lot of other libraries for us to use, like dplyr and readr and whatnot, and ggplot2, which is the plotting tool that a lot of folks use. But if you quickly take a look at the format of his code, their script at the high level, he's got it separated out into loading the libraries. I believe that's Portuguese, what he wrote there. The functions that he's going to be using, which is a great technique to be using, is any functions that you're writing that you're going to be using them, putting them up at the very top of your script along with your libraries, just makes your code really organized, so you don't have weird sections where you're defining a new function and then you're going back into more of your R script processing. You have everything defined at the very top, and you're just able to go through all the processing.
Yep.
So here's where he's defining that function. Here's where he reads in the data. So he's using the URLs, the slugs, to access the Tidy Tuesday data. He's loading them all in. He does some processing, and then he does some plotting. So this step here, like I said, he loads in all the data. So let's start running this. All right, so we loaded Tidyverse, built the function, and downloaded all the data from GitHub. And so then this step right here, it looks like what he's doing is he's taking the TBI age data set, which looks like this. So it's got a couple different columns there for us. Age group looks like, then what type. So not quite sure what that is. The injury mechanism. So what caused the injury, the number of folks that happened to, and then rate estimate. I'm assuming that's some sort of percentage or number of people per 1,000 or million that happens to.
Mm-hmm.
Then, all right, so what he's trying to do is he's processing the data. So first he takes TBI age and keeps only the cases where there are deaths. So it looks like type is, what resulted from the TBI. So there might be a number of types of type there. So it looks like there's 3 different types that populate the type field. There's emergency department visit, hospitalizations, and deaths. So he only keeps the deaths, so to get the count of deaths that occur, and then filters by age group. So in this situation, it looks like he only wants to keep some specific age groups that are defined by the age group column. He has to do that because there's several different ways that they define age group, it looks like, in this data set, where they have age 0 to 17, but they also, for death, it looks like, have smaller binnings of 0 to 4, 5 to 14, and it looks like jumping by about 10 years until they get to 75, and then anyone over 75 is grouped into a larger into the group.
How many? Yeah. Can you run the unique on age group, and let's just see what they have, because they have all these large buckets like 0 to 17, and which is really interesting.
All right. No, not type. We just looked at type. So yeah, so it looks like they have a binning for anyone under the age of 17.
Yeah.
And then, but I don't see like a 18 to whatever group.
Yeah, it's interesting, isn't it?
Yeah, and then there's a total. So I'm assuming that's just across all age groups, total number of cases. So for Raniere's visualization, I guess he only wanted to use these age groups here. He didn't want to look at a total.
Yeah.
Then this next step,
remove the 0 to 17, because you'd be double counting everybody in the 0 to 4, 5 to 14, and then half of the group in the 5 to 24 group, it looks like, if you were to use 0 to 17. So that's why he doesn't use that, I guess.
Mm-hmm.
Yeah.
All right. And then in this step here, he's using factor on age group, so he can then define the various levels that exist. So right now, this is a character value, right? And what he's doing with this factor here is telling R a couple different things. So first, he's defining the order in which the factors should appear. So first, he wants to see 0 to 4, then 5 to 14, and then last, he wants to have the 75 plus shown in factors. To be clear, this is not actually ordering them. So he's not in this because he's not defining it as ordered. So you can have an ordered argument here, and so you can set that to be true. Normally it's false. So this is not setting a preference, so not a rank order to it. So a nice way to think where ordered might be valuable is if you were looking at like first, second, or third as a string, where the actual number 1, 2, 3 is not a true number, right? Like it doesn't matter that they came first, second, and third. There's not third place isn't 3 orders of magnitude worse than first place. It is there's an order to it, but it's not an actual numeric value, right? And so then factors also make it easier to handle for statistics, different groupings where you're defining like placebo or not, and you're able to use words rather than using dummy variables like 1 and 0 and having a column called placebo or treated. At least that's how I see it most commonly because I work in a pharmaceutical industry, but I can imagine other places where that might be used. Patrick, do you use factors much?
Yeah, all the time in models, just because, yeah, like you said, we don't have to go through and explicitly create a whole host of dummy variables, and you can have your outputs. Some of the models also will in R, like some of the functions and the models need the variable to be defined as a factor. It won't take like a 0 to 1, even though it might be a classification problem anyway. So it's used pretty frequently. Yeah.
Mm-hmm. Great. So he's running this on age group, but then rather than overwriting age group, it looks like he's creating a new field called age group F. So age group factor is what I would assume there. And then he's throwing it into his function that he defined earlier, which he called ggplot TBI age. So let's take a second and look at what he actually wrote here within this function. And this is a really nifty way to make your life easier if you're going to be doing the same sort of plot fairly often, is to actually define it within a function, because you can then reuse the code without having to copy and paste it and then potentially introduce errors that way. Mm-hmm. And in this situation, it's actually a rather simple function, the way that he did it, where he only passes data and then the title that he wants to have output. But you do have the potential to really customize your ggplots within a function. But I don't think we'll get into that at this point. All right. So what he's doing here is first into the ggplot. So this is defining the ggplot object initially. Is he's going, okay, now pass data into it, and then set the aesthetics to be the x-axis is the injury mechanism, the y-axis is the number estimate, and fill, so set the coloring as an injury mechanism. So right now, if you just try to run this ggplot, it's not actually going to produce anything. But he's just he's telling it, okay, now for all these additional layers, here's how it should behave. And so you can define this in your ggplot, or you can actually define it later on within your geom. Next, he's defining the facet. And so this is a way that you can pass your data into it and actually create multiple facets, is what they call it, or panels of the different data. And so here he's defining it as age group F. And so you know how we converted that into a factor earlier. So now when he passes it through, it's going to order all of the panels. So it's going to subset and keep all the cases where like age group is from 0 to 4 and generate the plot only for that subset of data. And it's going to do it for each of the factors that he has there. And so that's why he also ordered it. So now it'll show it numerically from 0 to 4 and then 5 to the next age group, all the way up to 75 plus. All right, next he uses geom bar, which is, a bar plot. But since he actually has the values that he knows he wants to be using, he uses stat identity, or stat equals identity. In this case, you could also use a geom call. I believe we talked a little bit about this last week in episode 2. Now the cool part that we thought was awesome, and why we want to discuss this, is the power of the chord polar. Patrick, do you maybe want to talk a little bit about what chord polar is?
Yeah, the chord polar is just going to basically take his geom bar and sort of spin it out into like basically coordinates of a circle. And there's lots of things you can do within that function. He left it blank, but changing things like width will change the size of each of the essentially bar plots that are turned into a piece of a circle now. So we could play around with some of that stuff and show what happens when you change it. But you could change the width. You could change different colors that are going on between each of the bars. So sometimes if you have the width as 1, meaning they're going to fill up each of their respective regions, you could set the color to something like white, and that'll have some sort of separation between them, things like that. So there's a lot of different things you can do in there. But basically, in a nutshell, what it's doing is he's creating a bar plot, and then with chord polar, he's saying, take that bar plot and put it on a circle.
Mm-hmm. Mm-hmm. Great. All right. So then it looks like the rest is relatively standard ggplot code. Which is, the power of ggplot is the fact that you can do so much with, standard code where he's defining the title of his ggplot2, which is an argument in his larger ggplot TBI age function. He's removing the X label. I guess he doesn't want that. He's setting the Y label to be he's defining it in this situation here, the established or estimated observed cases in 2014. He is then going to scale he's setting the coloring by injury mechanism, which was done here too. So I guess I'm not quite sure why he's doing that again down here. He's setting the name.
If you he must be. Yeah, injury mechanism is going to come out as the legend. So he didn't want that underscore. The other thing that you could do there is you could do name equals injury mechanism and then add a comma and use the values argument. And so depending on how many groups he'll have, you can set different color values that if you don't want this standard, right now he's going to get the stock color palette, the default color palette from ggplot, but you could set your own color palette, or you could choose whatever colors you want. So that's where you would usually use something like scale fill discrete.
Mm-hmm. All right, and then this part here is he's setting the theme. So he's actually saying he doesn't want any ticks or any text for the x-axis, and he's removing any of the axis ticks. Mm-hmm. All right. So the nice thing about this is now that he has this function here, so it's predefined, and so he's just able to pass his data into it. So he's got the data defined here. He's got his ggplot already defined, so he's able to run that. It helps if I have been running the code as I go. Now running, and it's generating the ggplot for me. And would you look at that? All right, so it didn't. There we go. Now it shows a little bit better. My window is a little bit small there, and this legend here is pretty wide, so it's eating up a lot of the space. But so when you're looking at this data, there's nothing here in the 0 to 4 and 5 to 14. At the very least, the values are so small that we can't see them because we're at a scale to 10,000, right? And so he also saw the same issue, and what he did is he removed the largest mechanism for injury, which is purple, and it's shown in the 75 plus, which is unintentional falls, which I guess isn't too surprising that the 75 plus group might have a lot of unintentional falls. It's unfortunate that happens, but it's skewing our plots, so we can't see anything for any of the other age groups because there's so many of that. So what he did is he went through and just removed that from his plots for the next plot. Oh, I guess I did skip forward a little bit. So then he saves it using ggsave. So what it's going to do is it's going to look, because we didn't pass an actual ggplot to it, it's going to look at what you have in the plots window of your RStudio and save that for you. So that's a fairly nice feature as you go. It is better practice to be saving it explicitly, but this definitely works. All right, so now let's run that. So now it's removed the injury mechanism from Datos. One suggestion would be, rather than overriding Datos, would be to rename it as filtered or removed, just to make it clear what's going on, because now you can't go back and rerun this and expect it to behave the same way, because it's different data that you're feeding into it. But because this is linear, this definitely works out. And he's renamed the plot. Now he's telling you, okay, now he's excluded unintentional falls from my data. And now he runs that, or now we run that, and hey, would you look at that? I mean, at ages 0 to 4 and 4 to 5, that it's still really small. Right? Yeah.
So, some of the things, instead of removing or just removing a group, plots like this become problematic when you're dealing with counts like that, because you're essentially a slave to whatever the largest group is, which we saw. Things you could try and do if you didn't want to remove the group. The first would be within your facet in the ggplot. He could have set something like scales equal quote free underscore y, And that would have basically allowed a free y-axis for each of the, what do we got, 9 groups there. And that would have essentially allowed, I don't always love doing that because you're now looking at different y-axes. So if you're looking across groups, it could kind of, I think it's scale equals.
So it looks like you can't do that with chord polar. It does not support free scales.
Oh, interesting. Oh,
So
okay.
interesting. So
Yeah,
this
there
would
you
work
go.
with a
So
bar plot if you wanted to facet by bar plot. So if you
yeah,
didn't
you could
include
do it
that.
by a bar plot, or you could so yeah, we could look at it if you want, but you could do it using the bar plot. I didn't know that you couldn't do that with coordinate polar, but essentially, yeah, what it does is it puts each one of those groups, each one of those facets, its own y-axis, which can be problematic because differences looking across them have to be taken into context that you're looking at a different y-axis. Another option would have been to like standardize the counts across some value. For example, maybe making them the percentage of death by traumatic brain injury for each of those groups. So then what you would have seen was the unintentional falls would have been a very large percentage relative to the other types of injury mechanisms. And then everybody, all of those facets would have been as some sort of percentage for each of their respective groups. So then because it's a percentage, it would be basically normalized to a value between 0 and 100%. And so that would get everything on the same level. And then you could be able to evaluate these in groups 0 to 4 or 5 to 14 wouldn't look so tiny.
Yeah, exactly. And then, all right, so then he saves it, also using the same GG save. And it looks like that's the script. So thank you very much, Raniere, for letting us go through your script and explain it. Polar plots are a great way to visualize the data in a unique way. There are some things to consider when you're doing it, but we thought it was a fun and unique way to view this data. So now we're going to apply the same theory of polar plots, but this time we're going to use a new data set.
Yeah. So I thought since we can't watch NBA basketball right now, it would be fun to play with some NBA basketball data from last season. So we're going to use this concept of polar plots to basically build an interactive Shiny app. And we'll talk through that, and we'll build an interactive Shiny app that allows us to compare 2 players. And it's it'll basically create a polar plot for each individual player that we select. So we start out just loading the packages there. And we added a package there at the bottom, which we haven't seen before, even though this is only our third TidyX. And this is kind of a new one to me. The library is called Conflicted, and I'll let Ellis kind of explain what that's doing and why he put that in there.
Yeah. So Conflicted is a library that allows you to define what functions you want to be using when 2 different libraries have the same function same function names. So an example here is if you go, here we go. When we loaded the library rvest, which is for web scraping, it overwrote from the package per, which is loaded through tidyverse, the function pluck. So we touch on that in a later bit, but a function that you might be more aware of is the function filter. And so filter is available in both plier and dplier. And so both of those come from the tidyverse, and they need to be loaded in a specific way. But sometimes you might prefer one over the other. For example, the dplier the filter function that comes from dplier is the one that most people recognize at this point. But occasionally you might want to use filter from plier, or if you're working with some of the base functions too, filter is a base function actually too. So you want to define that. So Conflicted forces you to actually handle cases where you have functions that are used by 2 different libraries. And so that's the way you do this. So what we do here is you use Conflicted prefer, and you go, okay, the name of the function I want to be using is pluck in this case, and the library that is the version that I want to be using is from per. So you set winner is equal to per. So now every time I use the function pluck, it'll go, oh, okay. R will go and start looking for the function pluck in my namespace and go, oh, the version that I'm supposed to be using is per. So it'll identify that for us and use it. And the same situation is happening with filter in this situation. Is it's going to use the dplyr version of filter every time we use filter. And this is going to protect you from accidentally, later on if you load in another library, or, if you load dplyr after dplyr, this is now going to protect you from accidentally using the wrong version of filter. And it's not always obvious as you're going through that you are using the incorrect version of it until you get some weird errors as you go through. So let's run these.
And those two, yeah.
All right, and there we go. So now it's saying, all right, now I'm going to use per pluck.
Yeah, cool.
When we use it.
There we go. Then I always set the theme because I'm not a fan of the default gray theme of gplots. I always set my own theme. So we'll go through. I get the URL from basketballreference.com, which is the players' totals from the 2019 season. So I read that URL in. And then in the next bit of code, I basically say that from that URL, I want to scrape the first table on that page. And I did it with just kind of a little base type of coding there with the dot bracket 1 to tell it that I wanted the first table. You could have done this with the per package, like Ellis talked about that function pluck. And that would have been the sort of tidyverse way of doing this. Either way is fine. And then I filter out if you go on the basketballreference.com and you look at the actual web page, you'll see after about every 10 players, they give you the column headers again. So basically all I'm doing is filtering out all the extra column headers from that table to get just players so that I don't have a bunch of unnecessary data in there. So it's going to take a second here and read the data in. It's already done. And then we take a glimpse of the data. So again, this is basically just like in base R. If you were to use str function, it just kind of gives you a look at what the data values look like and information about what type of variable it pulled in. So you can see really quickly all of the variables. I think all the variables are characters. Did it pull them all as characters?
Yeah, they read them all as characters.
So that's going to be a problem, obviously. So when we get down here to this pre-processing step, I just write a little bit of code that says find the numeric columns. So I set those columns as columns 1, 4, and then columns 6 through 30. And I say if in the NBA data you identify column 1, 4, or 6 through 30, use this little apply function and basically convert those columns from a character to a numeric value.
Mm-hmm. And so, so apply is from, like, there's a family of functions called the apply family of functions. And so these existed, so these were created and exist in base R, and they are like for loops, right? Or they're like a group by summarize or something like that. So it's a way to quickly run a function across a set of values quickly. So what this is doing is apply. So it's going to apply across each of these. So you're subsetting the data to only keep the numeric columns there. This 2 is telling apply only run it column wise.
Yep.
Right. And now it's going, okay, now apply this function to it. And what you're doing here is you're making sure that it's a character, because if it's a factor and you call numeric on a factor, it'll actually return the level of the factor as opposed to the numeric value that it is. That's a common mistake that happens that I see a lot, is somebody will call as numeric on a factor, but they don't realize that what it's actually returning is the level, the numeric value of the level of that factor as opposed to the actual numeric value.
Yep.
And so then what this does is it returns a list, I believe.
This won't return a list. lapply would return a list.
Oh, okay.
So there's different ones. There's like mapply, lapply, apply, right? This will just give me the data just like that. There you go.
Oh, that's nice.
Yeah.
And so then it's going to run it and then drop it back into the NBA data frame with these updated values. So it's going to overwrite them with the corrected values.
Yeah, that's right. And so it's a pretty handy little function. I think if you're using in Python, I think they call them lambda functions, like do the similar thing. You can pass a function across several things like that. I believe it's called lambda in Python. But so we got it. So if we hit glimpse there, now we'll see we have the variables are numeric. And then we see also I left by defining which columns I wanted to convert. The columns that I didn't define, they're left the same. So player is still a character, position is still a character. And so now we're ready to kind of move through this. I didn't want to do every single variable. I felt like the polar plot would get kind of busy, so I just selected a few out for fun. So you can see right there, I identify the columns that I was most interested in, and I also changed the title of the one from Basketball Reference. It's called 3P. I just changed that to 3 points so that it was clear what I was looking at there. There's several players that obviously get traded or cut from a team and then get picked up by another team. So I wanted to make sure I was only looking at single instances of players for the entire season. So I do a kind of a summary data set here. I rename my original data set and call this NBA main. I group by player, and I just summarize at each of the numeric variables in my data frame. And just basically summarizing over the player name. So if a guy was on 3 teams, it's going to sum all of his data. Yeah. Quantile NBA main is minutes played is just looking at what kind of distribution of minutes played. So obviously we have got a few guys that played a whole host of minutes, over 2,000. And then we have one guy that actually got in for a single minute. He was probably paid pretty well for that 1 minute.
Relatively.
Yeah, relatively, right. So the next thing I did was I just said, okay, put all of the stats on a per minute basis so that we could just kind of look at them as a per minute basis. And also I just did a quick and dirty median split. There's other ways that we could have handled this or identified the players of interest, but I wanted to get our basically our player list down to guys that we would consider guys that played in the 2019 season. So at the end of summarizing each variable by dividing it by per minute basis, I then just identify any of the players who were above or equal to the median minutes played, which was 1,174. And then I remove that column altogether so that I'm dealing with just a data set of player name and minutes played.
Mm-hmm. The additional benefit of removing players that played less than the median would be it's going to remove any outliers. So potentially a player that came in only played, that 1 minute, but somehow miraculously was able to score 4 or 5 points in that 1 minute would have a really high, points per minute percentage that would dwarf any of our other players. But realistically, they only played for a minute. And so if they were to play longer and play more, their points per minute would realistically drop closer to the median. Of all players. And so this is a quick way to simply, get rid of the outliers that just didn't play a lot. So you don't have a lot of data on them.
Yep. So now we get into just normalizing these columns. So kind of like I talked about with Raniere's plot, when we have those groups with really big numbers, what we're dealing with here is we're dealing with a bunch of values, and all of these values are kind of similar now that we put them on a minute basis. But if we were dealing with something like counts, we might have a situation where some values are really, really large. Like let's say we're dealing with this data as a count data. We might have a guy that played 3,000 minutes and he might have scored, let's say 150 points. So, or maybe he only had, 50 rebounds or something like that. If we were to just plot the data as is, everything would be, again, you're a slave to your largest group. Everything would be sort of dwarfed out by the minutes played. The other reason, even though, again, we've put everything here on a per minute basis. And so we kind of standardized it that way. The other reason that I go ahead and I put these into like a z-score, standardized score, and then change it to a t-score is that if you're trying to reflect this back to an audience, it sometimes is easier for them to understand things as, let's say, like a 50 is average or 0 is average, and then maybe the values climb from 0 to 100 or something like that. So I first do a z-score, which basically takes the player's value and subtracts it from the average of the population and then divides that by the standard deviation of the population. And so I run that for all the players. I run that for all the columns of the data. And then I do a t-score, which basically takes that z-score and it turns it into a score basically from 0 to 100. And so again, 50 is going to be average. And so we'll use that in our plotting to sort of create a reference point around the polar plot that gives people somewhere to look at and say, like, okay, if that's average, what does this guy look like relative to the average NBA player who played a median number of minutes? So we go and we calculate all that. Everything's now on that 1 or that 0 to 100 scale. So if we were to kind of run that little thing there, that's sort of my sanity check of what did the data look like. We should see that our median values are right around 50, and this looks pretty good. So it looks like we don't have anything crazy going on. So I go ahead and I take all the data and I put it into a long format. This just makes it easier for plotting. So it makes the code a lot simpler to write. I don't have to write a bar plot for each individual variable if I do it like this. And I also rename each of the columns. And I do that because I want them to appear on the polar plot in this fashion. And so I also use that little operator we talked about, that little character we talked about last time, the \n, which gives a new line. So it's going to basically show up on the plot as FG new line per minute. And so I want that because I don't want the variables to take up too much real estate within the plot. They'd be really long and it'd be difficult to kind of look at. Mm-hmm. So we go ahead and we reshape all this data into a long format. I use melt. Again, you could have used what would have been, it would have been pivot longer, I think.
Yeah, pivot longer is the this current way that it is suggested to be moving your data from wider to longer formats. Conversely, there's the pivot wider function that makes it from a long data set to a wide data set. There's been a few different iterations in this in the tidyverse. There used to be spread and gather. It was decided that the arguments that go into spread and gather were not super clear to a lot of people. I mean, I know that that's the way that I like to do a lot of things these days, but that's because I'm biased to it because I've been using it a fair amount. I'm starting to get used to the pivot longer and pivot wider names of the arguments and the order in which you're supposed to be putting them in. But it tries to make it really clear where you're taking the columns 2 through 7, you're going to make it longer, going to name all the column names, move them all to a column called variable, and then you're going to take all those values and put them into a column called value. Yeah. And so it's just a different way to do it. Melt is from the reshape package, I believe. Pivot longer is in tidyverse. Once again, whatever you're most familiar with is probably the best way to do it. In this case, Patrick is the most familiar with melt. It's the easiest way for him to start doing things. So it totally makes sense for him to do it that way.
So before we did the before I build any Shiny app, I usually like to get a sense for what kind of plots I want to build and how they might look. So I built this simple plot using LeBron James. I grew up in Cleveland, so I'm slightly biased to him. So if you go ahead and run that, we can look at what that looks like. And so in here, again, you can see I have width set to 1 in the geom call. If I were to change that, I could set that to, like, let's say delete that and put in 0.65, right? And then rerun it, and you'll see that the size, there's more spacing between the bars, which we've turned into this sort of circle. Okay, so that's kind of cool. That's one iteration. And then I thought, well, what if we wanted to compare players? Would it be cool to put 2 players on the sort of same coordinate polar plot? And I was like, okay, this is way too messy for me to understand. So So I decided we're going to use the first version, and we'll create a simple Shiny app that allows us to compare one player to the next by us self-selecting that defined player. So we get into our Shiny app here. I just quickly create a simple table of the raw values that we'll use to accompany our plots. So again, because I was iteratively going through the data and renaming the data frames when I went to normalize the data, I can go back and do these sorts of things because I didn't overwrite the original NBA data that I pulled in. So we got a table data now. I create a list of player names, and that just allows me to have these players be selectable within our Shiny app. And then we get into defining the user interface here. Like, there's no way around this. I find the Shiny text or the Shiny syntax to be a little bit challenging at times. So what I usually do is to keep myself sane, is I sort of have this shell that I can create like one single selector with one plot, and then I have a server that plots that plot, and I always start by working from that shell. So this is what we've got for our user interface. This is the part where the individual is going to be able to mess around with the data on a web page and select the player and things like that. So we've got the title of the panel. We're going to call it 2019 NBA Performance, and then we've got our main panel. And so we've got a split layout, which basically is saying we've got two graphs, two players, two selector boxes. Ellis, you can go ahead and talk through this. I had one thing, you kind of dialed this up a bit so that we could make it look a certain way.
Sure thing. So what I did is, so main panel is, and the width equals 12, is telling it that this main panel is going to be the full width of your web page. Next, split layout is defining you're going to have two basic boxes, essentially. At least that's the way that I like to think about it when I'm working with HTML. Two boxes that you're going to have side by side. And in total, they're going to add up to the 100% there. Then you use this div tag. So it's a function that's available through Shiny called div. And think of that as defining an area. And so within the parentheses there, everything is going to be within the box of div. And it's going to, by default, stack everything because we didn't pass any additional styling or CSS or HTML code to it. So what it's going to do is going to allow us to input the select input, which is allows the user to select the player. In this case, what we're doing is they can choose from any of the players because we passed that as one of the choices, or the choices there. But by default, it's going to select LeBron. It's then going to be stacked on top of the plot. And so this is the radar plot that we're generating. So this is defining this area is going to be a plot. And then we put the second player also like that too, where we're going to have the ability to pick any player. By default, it's going to select, they can select any player. In this case, it's going to pick the first one from the player vector, and then it's going to plot a second plot as well. So there's two different inputs, player one and player two, and they can select literally any of the players that exist within the players vector. And they're beneath them, they're both going to have the radar plots that we're generating, or the polar plots that we're generating of how they behave or how they performed according to various metrics. And then finally, underneath all of that, so split layout ends here. Underneath that split layout, we're going to have a table that's going to show the actual statistics for each of the players. And so that's what the UI is going to look like based on this UI function that we're going to build here. So we're going to run that, and then if you print the UI, you can see a bunch of HTML that's going on there. But we don't have to worry about that because the folks at our studio built out this this HTML tool really nicely, so we can just write it all in R and not have to worry about a lot of that. And then we get into the magic of Shiny, which is the server bit of the server function, which is going to be running in the back end. So the way Shiny works is you have a UI that's in the front there that's allows the person to be interacting with it, and things are going to be able to appear based on what they select. But that's all run in your server function. And so it takes a little bit of unique thinking, I find, to work with Shiny apps. But the way that I like to do them, because I typically am not building any complicated Shiny apps, is to think about them relatively linearly. Patrick and I are definitely not experts in Shiny. We can work our way through them. If you want to learn more about Shiny, there's loads of tools online that you can find on how to build really great and really complex Shiny apps that exist. And so, Patrick, do you want to take them through the logic here?
Yeah. So I kind of commented out there so that you could see what I was doing as I worked through this. I create 3 separate data sets, one for each player for their respective polar plot that we'll be able to select. You can see player, I use a subset there, and I use player equals input, which is coming from the user interface. And then I'm inputting player 1 and player 2. And then I build a third data set that's specific to the table that we define using both players 1 and players 2. So subsetted from there. And then we scroll down and we create those actual plots. So there's plot 1. This is literally pretty much the exact same ggplot code that I had above for the LeBron James example. I've just turned it into this renderplot function, which basically allows it to take an input from the player selection and then turn it into some sort of interactive plot. Plot 2 is the exact same thing, just for player 2. And then obviously output the player table. We render a table that will take the input of the 2 players and produce their data. And so after we run the server, we go ahead and we can run the Shiny app, and we're ready to go. There we go. We've got a cool little Shiny app. We can look at it there in that window, or we can open it in a browser, either way. But so we've got LeBron James. You can see that I did some stuff with the like I talked about in the previous example, changing the colors. So I actually set the color palette that I wanted rather than using the defaults. I also passed a black circular line at 50, which represents the average. And I set the Y limits to be 0 to 100, which is really important because what we have is 2 separate plots. So what might happen, or what will happen if I don't set the Y limits, is that ggplot will automatically define the Y limits that best fit the data. So it'll best fit for LeBron, and then it'll best fit for Aaron Gordon. And so it'll make their plots look very different because they're not on the same Y axis. So I just set that. So we can select other players. So for example, there we go. There's Andre Drummond, Andrew Wiggins. We can select players and look at how they perform relative to their peers. Again, this is players that had a median, who played more than the median amount of minutes for the 2019 season. And you can see too, when you change players, you'll see the bottom table also change. So we're looking at Wiggins and Lonzo Ball right now. We can select other players, and you can have a lot of fun with this. We could put in tabs that basically are for position groups. If we wanted to look at players by position group, we could scrape the game to game data and do like time series plots of the player over a season and things like that, or put in extra tabs that might look at these players in different ways. So this was sort of just a simple version using the polar plots that were created for this week's Tidy Tuesday.
Mm-hmm. Yeah. And so we also decided to actually serve the Shiny app so people can play around with it if they want to. We decided to serve it through shinyapps.io. So just give it a second. It's running. And so this is a service offered by our studio where you can run your Shiny apps through there. They have various levels. This is the free level, so it might stop working if too many people go to it. But they need to limit the number of people. So this is behaving exactly the same as it did on my computer. And so it's a really fun way to be able to go through everything. So that was an example of how you can use polar plots to show various data sets from TBI to NBA. Thank you, Raniere, for letting us go through your code and share it. And thank you, Patrick, for sitting here with me again.
Yep, absolutely.
To do this. thank you all for listening. If you can rate, subscribe, follow Patrick and I, you can find me at Ellis_Hughes on Twitter.
And I'm at OSP Patrick on Twitter, at OSP Patrick.
All right. Thank you and keep safe.